Students, this is Cambridge IGCSE Physics, paper 6 alternative to practical, October, November 2020. Question number 1 is already done in the previous video, and now in the second video, we are going to do question number 2. In question number 2, a student investigates the cooling of water under different conditions. Figure 2.1 shows the apparatus she uses. Now, this is the apparatus. This is a clamp. There is a beaker, a stand, and there is a thermometer, and the figure shows that the room temperature theta r at the beginning of the experiment. Now, this is basically at the beginning of the experiment means that this is the room temperature. That is why it's written as theta r. So theta r is the room temperature, and we have to find out that what is the room temperature. So I'm going to zoom it a little bit to see what is actual temperature. At the room temperature right now, the thermometer is showing us exactly 21 degrees centigrade. Why I put centigrade? Because it's written centigrade here. Okay. Next we have the student pours 200 centimeter cube of hot water into the beaker. So in the above beaker, there is a 200 centimeter cube volume of hot water is poured. She records the temperature of the hot water at time t is equals to 0. She immediately starts a stopwatch, and then after 180 seconds, she measures the temperature on the thermometer. So her temperature readings are shown in the table. Now this is the table given. Now what we have to do, we have to complete the time column and the column headings in the table. Now, at first, we know that the time at which she started was t is equals to 0. So it means this would be 0 degrees centigrade. And after 180 seconds, this would be like after, sorry, this is not 0 degrees centigrade, mistakenly I wrote 0 degree. It was the time t is 0. And this is the time which is 180 seconds. So after 180 seconds, this is the time at 180 seconds because it was initial time and it is the final time. Now the column headings we are going to write that this is the time in seconds. Because of the seconds, we got to know that the unit of time is seconds and the unit of temperature is degrees centigrade. So here all the temperatures are in centigrade. Okay. Now calculate the drop in temperature, that is delta theta 1, between the time t is equals to 0 and time t is equals to 180. So what we have to do at this time, we will be taking the temperature drop. Temperature drop will be calculated by using delta theta 1 is equals to, this is delta theta 1, which is 85 minus 69. So I'm writing 85 minus 69, and I got 16 degrees. So the temperature difference is 16 degrees centigrade. It's 16. Now, we got to know that this is the temperature difference. Now we have to calculate the average rate of cooling with the help of this equation R1, which is delta theta 1, which we just have found 16, divided by the time, which is delta t. Now we know that delta theta 1 as it is 16, and the time delta t was 180 minus, this would be as like delta t would be 180 minus 0, which is 180. So the time would be 180. So I'm going to divide 16 divided by 180, and I got the value 0.088, because this is the average rate of cooling. So we got this as, this was the temperature, and this was so centigrade per second, because this is the ratio, simple ratio. So we just found the value as 0. I'm just writing it here, 0.088. This is for delta, this is for rate of cooling, and delta theta 1 is 16. And delta t is T1, or delta t is 180 seconds. Okay. Now, moving on to the next part, where she said she did something else in the experiment. The student empties the beaker. Now she pours another 150 centimeter cube of hot water into the beaker. Previously, it was 200 centimeter cube. Now she poured 150 centimeter cube. Now she adds 150 of hot water and 50 centimeter cube of cold water. So basically, there are two things: hot water and cold water, and she mixes it. She repeats the timing and temperature recording. This time, this is a little bit different. Again, the timings are same. Time is 0 and time is 180 seconds. Again, the times in seconds, it is in it is in centigrade. The temperature recordings are this one. Now, this time we have to find out delta theta 2. It's given as, let's see, the temperature drop as delta theta 2. So let's find it out. Temperature drop, and that is 69 minus 57. So let's calculate it. It would be 69 minus 57. So it's 12. Now the delta theta 2 is 12 degrees. 12 degrees centigrade. Now delta theta 2 I'm writing here is 12 degrees centigrade. Okay. Now, what we have to do next, we have to move on to calculate again the average rate of cooling. The first rate of cooling was 0.088. Now we have to find out the average rate of cooling 2, in which we will be using the delta this time, delta theta 2. So delta theta 2 is 12. 12 divided by 180. This time we are going to divide 12 by 180. And this would be 0.066. So I'm writing R2 as 0.066. Now see, this was R1, 0.088, and see, this is R2, which is 0.7. Now what they are asking in the next question is, students suggest, okay, now look at it. A student suggests that average rate of cooling of the water depends on the difference between the temperature of the water at time t and the room temperature. Now we have to see that the time at t is equals to 0. D1 and D2 are basically from two different tables. So we would go back for the room temperature first. Remember, on the thermometer, we told that the room temperature is 21 degrees. You remember that was 21 degrees centigrade from the thermometer. Now we have to calculate the difference T1 as the room temperature and the time T is equals to 0. So let's move on to the table 2.1 first and then table 2.2. So table 2.1 is this one. So I'm going to calculate D1 by subtracting. It would be D1 as 85 minus 21. So I'm calculating 85 minus 21. So it's 64. This is D1. And D2 would be from the table, next table, which is table 2.2. So the table 2.2 says it at time t is equals to 0, because at time t is equals to 0, it's 69 here. So it would be 69 minus 21. 69 minus 21. That's 48. So the two values are here, 64 and 48. Now here we have got the values as D1 and D2. Now at the last, we have to write a conclusion between the relationship between R and D. We know that basically we will write that at time, let me write here, for R is the rate of cooling and D is the difference in the temperature. So D1 is 64 and rate of cooling 1 is 0.088 and R2 is 0.066 and D2 is 48. Now we can talk about, the conclusion is this one, and now we can talk about it, that basically when there is a major difference between the room temperature and the temperature at T is equals to 0, then the rate of cooling is also having a bigger value. But if the difference in the temperature at time T is equals to 0 and the room temperature is less, then the rate of cooling is also a small one. Now, so we need to move on to then, and in that particular case, they're asking us to know that explain why the thermometer should be reading at the right angles. So why the thermometer should be, because we have already talked about previously in the previous question, that the thermometer should always be, the thermometer scale or all the scale, the meniscus scale should always be in the right direction. Why? Because we know that to avoid the parallax error basically. So the important thing here is, what is, it would be to avoid the parallax error. So basically it's to avoid the parallax error. This is the case. And the next it is, they're asking us, explain why the temperature of the hot and cold water should be stirred before taking the temperature reading at the start of the experiment in C. So why mixing of hot and cold water should be stirred? Should be stirred means should be mixed before taking the temperature, because if she is going to take the temperature before mixing the temperatures are not going to be mixed and the even temperature would not be obtained. So to get the even temperature, it would be, we will write, so that we can get the, to get even temperature throughout. This is the reason why we talked about it. Now, moving on to, and this is all from this question, and for the next question, we will be talking about in video 3. Thank you very much.